Hello everyone. So this is the third problem of this contest, which is the divisible game. A beautiful maths problem with Kadan's algorithm, right? So let's read the problem statement. If you don't know, we have already uploaded the second problem of this contest, and we'll be uploading the next one as well. We'll try to upload for sure. So let's first read the problem statement. You are given an integer array nums of length n. Alice and Bob are playing a game. Alice chooses as any integer k, an integer k, such that k should be greater than 1, and two integer L2R such that the value of L is less than equal to 0 and R is less than n, right? Initially, both Alice's and Bob's scores are 0. For each index I in the range L to R, if nums of I is divisible by k, Alice's score increases by nums of I, else Bob's score increases by nums of I, right? So Alice wants to maximize the score difference. If there are multiple values of k, you need to return the smallest k which is possible, right? Return the product of the maximum score difference and the chosen value of k. Since the result can be large, return its modulo, right? So a beautiful problem, right? The what the problem state is, you need to first you need to return the product of k into the difference of Alice score, Alice minus Bob, right? And you need to maximize this part. You don't need to maximize the answer. When I first read the problem statement, this was my confusion, right? I thought that we need to maximize this part. No, you need to maximize just this part, right? And minimize this part. Means this should be as small as possible. If you can have a value which is smaller than any given value, that's more great, right? So the first condition should be to maximize this one, right? This is your first priority, right? And second priority is to maximize this, right? Great. So I hope till this point we are clear what the problem asks. Let's say take a test case 1468 and the value of k is 2 and L is 123, right? Okay, 1468, right? And the value of k for this case, just to understand the problem, I'm not saying that this is the solution or this, I'm not just uh, giving you a random stuff. I will explain how we will think about it as well, right? So for this case, if you take the value k from L equal to 1 from this place to this place, right, you will get the maximum answer. How? Let's see. If you have the value, this gets divided, so Bob's score gets added, Bob will get a plus 4. This also gets divided by 2, so Bob gets again a plus 6, and this also divides, so plus 8. Ultimately it is 10 plus 8, 18, right? And you need to return 2 into 18 because the value you chose was 2, so 2 into 18 will be your answer, right, which is 36, right? Let's look at one more test case so that we have a clear idea. So we have 2 1 2 and k is also again 2, right? So 2 1 2, right? And k is 2. So let's see, this gets divided, so Bob score gets added plus 2, sorry, plus 2 in this case, right? This does not gets divided by 2, 1 divided by 2 is 0, right? So this is not like 1 modulo 2 is not equal to 0, right? So this will be subtracted and this again gets divided by 2, so you will get a plus 2. So ultimately you get a plus 3 from this, right? We can name it as sum or score, anything which you want, right? And the ultimate answer will be 3 into 2, right? Which is 6, right? Okay. So the problem statement might be clear to you, right? In this test case, if you can, and one more thing, k was given was you need to have a value of k at least 1, right? Means the value of k should be greater than 1, right? If you look at this, the value should be greater than 1, not equal to 1 as well. So in this case, the value that you can choose is 2, the minimum value. So that's why the answer is 1e1e5, right? Okay. Let's look at the constraint. The constraint is till nums dot length is 10 to the power 3 and nums of I is 10 to the power 6, right? So the problem itself has a bit smaller constraints, or the constraints are not that tough, right? So we can write a solution which works in big of n square, where n is the size of the array, or we can do it in big of n, where n is the size of the array, into root of val, right? Now what is root of val? Root of val is the maximum value of the array, right? Maximum value, let's say 1e6, right? So this will also get accepted, right? 1e3 into root 1e6, which is ultimately 1e3 into 1e3, right? Which is 1e6, right? So we can write a solution which has a time complexity of this as well, right? Now first let me give you a first thought which I had, right? My first thought was, as we have to maximize the score, right? Maximize the score, right? We need to divide as many element as possible, right? Divide as many elements as possible. Yes or no? Right? Bob will love to divide every element, right? If it gets divided, that it is very good for him, right? And that is the sole thing. We want to maximize the difference. So you see now, if the my what is my score? My score is nothing but Bob minus Alice, right? So this number should be as large as possible, right? To get it as large as possible, I need to divide as many as possible. Yes or no? I think this is very obvious or pretty obvious for you, right? So to divide many numbers, we need to have the smallest prime factor with us, right? Smallest prime factors, or rather prime factors with us, right? Now you might think why prime factors is helpful, right? Let's say we have many numbers, right? Let's say x, y, a, b, c, right? And I'm bringing out the prime factor of this number, right? Let's say the prime factor of this number is alpha, right? You tell me one thing, this alpha will definitely be smaller than x. It can be equal to x, but all the other prime factors will definitely be smaller than x, right? So isn't the best thing would be, rather than dividing the element every element with x, why shouldn't we divide every element with alpha, which is its prime factor? Yes or no? You might say, hey, means, have you any proof for this? The mathematical proof is very simple, right? Let's say if a number x, right, if I can write it as a prime factor, the value of prime factor, let's say alpha into, let's say, beta, right, where alpha is a prime number, right? Let me write it with p, right? Just to make things clear, I am writing p as a prime number, right? P into alpha, right? Now this prime number, definite if this prime number definitely divides this x, means this x can be 6, then the prime number can be 2, right? So 6 definitely gets divided by 2, right? If 6 gets divided by 2, then this 2 can divide all the numbers which this 6 could have divided, right? 6 can divide 12, 2 can also divide 36, can divide 18, can divide. So every number will have a prime factor of 2 as well, right? So why not break every number into its prime factors? Yes or no? Isn't this the very obvious thing? Because the more, see, let me give you one more test case. Let's say if your number was x was 6, right? And let's take a value of k was 4, right? Let's say in my array I have a 4, right? In my array there's all 4s, right? And one 6, right? You tell me one thing, wouldn't it be better if I take the prime factor of 6, which is 2, rather than taking 6? Because if I take this 2, I can divide the whole array by 2. Yes or no? Right? So the best thing would be to take the prime factor, because this prime factor definitely divides this 6 and also divides all the number which are multiple of 6, as well as all the numbers which have a prime factor of 2. So the more numbers you have in your side, the better is your answer, because we saw that the sum will be nothing but Bob minus Alice, and Bob will get a sum only if the number is divisible by that value, right? So I can take the number as the prime factor of this value. I hope this proof was enough for you to believe that this is correct, right? Now you might think, hey, how many prime factors will you have? How many prime factors will you have, and how will you store that? Yes or no? How many prime factors will you have? So I did a research, right? Not type of research. I did a simple brute run to see how many numbers we can have, right? So if you look at this, right, the prime numbers, let's say 2, then 2 into 3 6, 6 into 5 30, 4 into, then you can do so on and so forth, multiply till every number. And if you see only 8 prime numbers, only 7 prime numbers rather, does form a number which is of size 1 is 6, right? And your nums was, you can see, is still 1 is 6, right? So it definitely means that any number, right, if you take the smallest prime numbers as well, it can't have more than 7 prime numbers in it. Yes or no? Am I making sense to you? The unique prime numbers can't be more than 7 unique prime numbers, right? So every number will have, can have 7 primes. This can have 7 primes, this can at most have 7 primes, at most 7, at most 7. This won't have, any given day every element won't have 7 prime numbers. But still, for your convenience, I took, because I don't want to lose generality, so I took that every element had 7 prime numbers, right? So in that case as well, if your n was, there was, and there were n elements, still you will have 7 into n prime numbers, right? And 7 into n is 7 into 10 to the power 3, 1e3, which is 73, which is ultimately in our bound, right? So if I get every prime number which I need to add, right, so I saw that I can have at max 73 prime numbers, right? After having 73 prime numbers, what I can do is I can store them in a set, so that every element, every, there is a unique element, you don't repeat the elements, right? And after that, what I can do, I can simply check if that number divides or not, right? Let's say if that number does not divide, right, does not divide, then you will add a minus, right? That number gets subtracted from my total sum, else it gets added to my continue, or gets added to my sum, right? Now comes the beautiful part, that is the Kadans algorithm. How is Kadans algorithm used? You will see, like, let's take this case, the first case, right? 1462, right? 1462 68, right? And k value was 2, right? Now you see, let's say I started with this point, right? When I divided 1 by 2, I saw, hey, the sum became minus, sum is minus 1. I will say, hey, there is no use of taking this subarray, right? Rather start from this point, rather start from the next point, right? When I started from this next point, this got a value of plus, this got a value of plus, and this got a value of plus. So I can simply say, hey, reject this value. So how can I do this? Kadan's algorithm is simply based on that. It says that if your sum is less than 0, right, then simply do sum equal to 0, right? You will say, hey, I won't be picking up that subarray which has a length, which has already get a value of less than 0, right? Because see, that's how I hope you know a little bit about Kadans algorithm. If not, let's quickly give you a small Kadans algorithm example so that you can understand how Kadans algorithm work. Let's say I had 4, let's say I had minus 100, then I had at 1 2 3 and 5, right? Now Kadans algorithm works in this way that, hey, what is the maximum subarray sum in big O of n you need to find, right? So let's say if you pick this element, your sum becomes 4, right? You pick this element, your sum becomes minus 96. Now you tell me, okay, let's continue. When I go to this element, you tell me, should I start fresh from this point, or I take these elements? No, definitely, because minus 96, even if you add some value, even if you add a greater value to it in future, why would you have a burden of having a minus 96? Start refresh, right? Start refresh is, I think, the bad wrong word. Have a get a refreshed value, right? So make the sum 0 and start from here refreshed. So sum becomes 0 and you start from this point, leaving behind whatever the sum you got, right? So this is what Kadan's algorithm is. If you don't know, I think you might have known about this. So even if you don't know, just search about Kadan's algorithm. I hope I have given a brief overview of what Kadan's algorithm is and how it works. Still, you can go and search about Kadan's algorithm. I hope it was clear to you till this point, right? So we will simply use the Kadan's algorithm, right, and ultimately return the maximum sum which is possible. Return maximum sum of difference, right? Maximum difference between Alice and Bob, or rather Bob and Alice, whatever the name was, right? uh, I hope the Alice was the name, right? So Alice minus Bob. So we'll store this and ultimately return whatever value is k value into difference, right? So it was pretty straightforward once you got to know that, hey, we need to do these things, right? So let's quickly look how we will do. One more thing, I have inserted set dot insert 2, as you can look in the code. Wait, give me a second. Yeah, so you can look in the code. I have done set dot insert 2. Now you might think, hey, why did you do that, right? Because see, element 2 is also is a prime number, right? So when you insert that into any number, let's say if the array had only ones, right? So you don't need to explicitly handle that case, right? So that is the reason I have inserted 2. Even if any element does not get divided by 2, it doesn't matter to me because other elements will take care, right? Other set elements will handle those cases, right? So I have inserted a 2 so that all elements which are 1, which is the third test case, will be handled using this set insert 2, right? Because 1 does not have any other prime number, right? So now what I'm doing is I'm traversing on all the elements and I'm creating a solve function which passes the set and the nums of I value, and we are finding all the prime factors which are there of value, right? So what I'm doing, I'm traversing from I equal to 2 to I into I less than val, right? And I'm checking if the number is prime number or not. If it's a prime number, I'm inserting the value in my set, right? And continuing forward, right? So this is the basic thought of finding the prime number, which takes big of root n time complexity, right? I hope you know about it. If you have any doubts, right, do drop in the comments. I will try to help you out there as well. Yeah, so this was to find out all the values, all the prime numbers which are there. So creating a set helps us reducing all the redundant values, right? So what I do is I am creating an answer which is minus 2e 1e18, right? And value of k which is 2e9, right? And I need to find as small as k possible, right? So what I'm doing, I'm traversing on all the value of set. I showed you that the set cannot have more than 3e7 or some value, something like that, right? So we will traverse on all the value of set, right? We take out the value, right? The top value. And what I will do is I will try to divide, traverse on all the elements on my array and see if that element gets divided or not. If it gets divided, then I will add it to my sum. If it does not get divided, then I will subtract it, right? And I will simply update my maxi as well, right? If my sum is less than 0, sum becomes 0. This is the basic Kadans algorithm thing, right? And after that, I'm checking if my maxi is greater than answer, then I will update my answer. Else, if my maxi is equal to answer, then val k is a minimum value. You don't need to like no, I think you might be understanding that, hey, if max is equal to answer, you need to find the smallest value of answer, right? So val k is minimum of val k comma val. Val is the element of the set, right? Set dot top, the first element of my set, right? So after the loop ends, we simply return the value, which is let's store the value as a result, and result is answer modulo mod into val modulo mod sorry, modulo mod. I hope this makes sense to you, right? And if my answer is less than 0, I simply do result plus equal to mod. A basic thought, when whenever you are traversing on these cases, you will get a value of -2, right? So doing a modulo value will lead to if I know, I think don't think I need to explain this, but still this is a modulo property, right? If you don't know, do drop in the comments. I will try to help you out in that as well. So ultimately you will return the result, right? This is a modulo property. If you don't know, I can help you out, right? And ultimately you return the result, right? So this is a special case where result is less than 0, and you need to simply explicitly hold it with result plus equal to mod, right? So this was it for the problem, right? If you look at the time complexity of the problem, it is nothing but big of n root n, right? It is, let me write it. So the time complexity is big of n root n plus big O of n into set dot size. Set dot size, you saw that it can be at max 3, 7. Let's call it n as well. So it will be big O of n root n plus n square, right? And n is till 1e3. So you won't have any difficulty solving this problem, right? So that was it for the video. I hope you understood the problem statement. If yes, do drop a like. We have a Discord channel as well. You can join there as well. If you want it, you can ask for the Discord link. Thanks for watching. Do subscribe, like as well. Thank you.